All right, in this lesson, we are going to talk about the quadratic formula. And so when you have your setup, ax squared plus bx plus c equals 0, you can find the solutions using the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a song to help you remember that. I'm going to spare you and not sing it, but I want to show you how to use it. And so I'm going to do 4 examples where we are just setting it up and using the quadratic formula. Pay special attention to the number we get under the radical. That expression is called the discriminant. B squared minus 4ac is called the discriminant. And so depending on what we get, it determines what kind of solutions we will get. Let's just do some examples. And so for this one, I can see that my A value is 1, my B value is 5, and my C value is 6. And so to set up the formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The more you write it, the more you'll remember it. And so negative b is negative 5 plus or minus b squared would be 25 coming from the 5 squared minus 4ac all over 2a. Just plugging in each of these values. And so b was 5. And that's how we got the 25. C was 6, and A was 1. Okay, and so now I like to number crunch the expression under the radical, which is called the radicand or the discriminant. And so 25, and then 4 times 6 is 24. So 25 minus 24 is just a 1. And then that 1 is actually a perfect square. We know the square root of 1 is just 1. And so we can break this into the 2 cases. We have negative 5 plus 1 over 2, and we have negative 5 minus 1 over 2. Negative 5 plus 1 is negative 4 over 2 is negative 2. Negative 5 minus 1 is negative 6 over 2. Gives us negative 3. Okay, and so we end up with being able to simplify all the way to 2 rational numbers. Okay, and so this is true anytime your discriminant is positive, first of all. Positive. And it is a perfect square. So this 1 was a perfect square. The radical is going to go away, and you're going to be left with 2 nice numbers. And so the way to say 2 nice numbers is real numbers. They're not imaginary, and they're rational. And so the way I kind of remember the word rational is think like a rational person. That's a nice person. They're reasonable. They're easy to get along with. And so rational just means they're nice numbers. Okay? There's no radical. You can simplify it all the way. In this next example, we're not set up just yet. We have to have equal to 0. And so we need to add 2 to both sides, giving us x squared minus 8x plus 9 equals 0. Now we're ready. So A is 1, B is negative 8, and C is 9. Okay, and so to use our formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so this time b is negative 8, and so we're going to plug that in. Negative b would be positive 8, and then b squared would be 64. Always positive for that b squared. Okay, and so that's where the 8 and the 64 come from. And then we have minus 4ac all over 2a. A is 1, and C is 9. Okay, and so to number crunch the expression, the discriminant, we have 64 minus 54. 9 times 4 is 36. Just kidding. 64 minus 36 over 2. And then the 64 minus 36 is 28, which is not a perfect square. Okay, and so our discriminant is not a perfect square, but we still need to simplify the radical. That's what our last lesson talked about. And so if you want to make a factor tree for the 28, that would give me 2 and 14, 2 and 7. The 2's pair up, and so that means a 2 can go outside the radical, a 7 stays inside. And so this simplifies to 8 plus or minus 2, and then 2 square roots of 7. And so like we talked about in our last lesson, if you have a GCF between all 3 of these places, you do need to simplify it. And so all of these numbers can be divided by 2. And so that would give me 4 plus or minus 1 square root of 7, and we don't write the 1. Okay, and so our final answer is 4 plus or minus square root of 7. That's our 2 solutions. One is 4 plus square root of 7. The other is 4 minus square root of 7. You don't have to break it up, but just realize those are 2 solutions there. Okay, and that's as simple as it gets. That's not going to be a pretty number. And so whenever your discriminant is still positive, but not a perfect square, you're going to end up with 2. They're still going to be real, not imaginary, but they're going to be irrational. They're going to have a radical involved. Okay, and so anytime you see the word irrational, that means radical. You're going to see a radical in there, a square root. Okay, we have 2 more cases. And so for this one, we're not set up yet. We're going to subtract 5x from both sides, giving us x squared minus 8x. And then we're going to also subtract the 2, plus 16 equals 0. Okay, and so here a equals 1, b equals negative 8, c equals 16. X equals negative b would be 8, plus or minus b squared would be 64, minus 4 times a times c, all over 2 times a. And so that's going to give me 8 plus or minus square root of 64, and then 4 times 16 is 64, all over 2. 64 minus 64 is 0. Okay, and so square root of 0 is just 0, and so that whole plus or minus part just goes away. Okay, so square root of 0 is 0, and so now we're just left with 8 over 2, which is 4, because this whole part goes away. And so whenever you end up with a discriminant of 0, you're only going to have one real solution, and it's going to be rational because your square root is gone. Anytime your square root goes away, it's rational, it's nice, it's going to be a nice number. Could be a fraction, but it's still not going to have a radical. Okay, and so our solution was 4. And then for this last case, let's get our setup. And so make sure your x squared term is positive. It's just easier to work with a positive x squared. So I'm going to add x squared to both sides, subtract 2 from both sides. And so that gives me x squared. I'm going to put the negative 4x next, so I have the right order. And then 15 minus 2 is positive 13. Okay, and so a is 1, b is negative 4, and c is 13. Okay, x equals opposite b, or negative b would be 4, plus or minus b squared is 64, minus 4 times a, which is just 1, times c. I'll go ahead and write it. Won't be lazy. All over 2 times a. So 4 plus or minus 64, And then 4 times the 13 is 52. All over 2. 64 minus 52. Oh, just kidding. 64 is incorrect because b squared is negative 4 squared, which is 16. 16. Okay, and then 16 minus 52 is negative 36. Okay, and now negative 36 is a perfect square, but remember, not negative, but 36 is, anytime you have a negative inside, that means you have to take an I out. Okay, that means it's going to be imaginary. Okay, and then we can simplify square root of 36 to just a 6. And we cannot simplify this other than the 4 and 6 divided by 2, which would be 2 plus or minus 3i. Okay, you can't combine the 2 and the 3. One's real, one's imaginary. And so these are our two solutions. They're imaginary. We have a 2 plus 3i, and then we have 2 minus 3i. Again, you don't have to break them up. I would prefer you to write them consolidated. It's just easier to look at. But in this case, when your discriminant is negative, you don't care if it's a perfect square or not. If it's negative, you're still going to have two solutions, but they're going to be what's called complex. They're going to have an imaginary part, which may or may not include a square root. In this case, it didn't include a square root. Sometimes they do. And so anytime you have a complex number, that just means you have I involved. Okay, and so just to summarize what we talked about, if your discriminant is positive, that means you're going to have real solutions, okay? And you're going to have two of them, two real solutions. If it is a perfect square, you're going to have rational solutions. They're going to be nice. If it is not a perfect square, you're going to have irrational solutions, which means you're going to have a radical involved. Okay? If your discriminant is 0, you're going to have one real rational solution. Okay? And then if it is negative, I don't know what color I want to use. Let's just use red again. If it's negative, you're going to have two complex, meaning there's an imaginary part to it. Okay, and so on the last page, what it has you doing is just determining the number and type of solutions, the number and type. Okay, and then we can use the quadratic formula to verify the solutions. So in the case of part A, all you have to do is calculate the discriminant to determine if it's going to be real or complex. And so once you identify A, B, and C, just calculate what b squared minus 4ac is. And in example 1, we get a negative 19. Because it's negative, we know there's going to be two complex. Because that's our discriminant, if you continue with the quadratic formula, you can get your solutions, and that's what they ended up being. On example B, our discriminant ended up being 0, and so we had one real rational solution. When we plug that discriminant under the radical and simplify the quadratic formula, we get 11 for our final solution. It's one real and it's rational. Okay, over here on C, once we identify A, B, and C, calculate the discriminant, we get 44. It's positive, but it's not a perfect square. So that's how we know there's going to be two real irrational, no I. Okay, in example A, it was negative and we had imaginary. We had the I show up. Here, no I. And then for example D, we ended up with 289 as our discriminant, which is a perfect square. I don't know where the Q went. It is a perfect square. And so that's how we end up with two real rational solutions. Okay, and then on this last example, it's an application problem, and they give us the equation to use. And so we would use that equation, and we can use the quadratic formula. It says how many seconds, the question is, how many seconds will the ball hit the ground? After how many seconds will the ball hit the ground? Okay, so if you're picturing what this quadratic looks like, it's a negative a value, so it's opening down. It's going to hit the ground at the x-intercepts. And so that's what we're finding when we're finding our solutions. Okay, and so when we use the quadratic formula, 961 is a perfect square. And so this whole thing simplifies to two real rational solutions. One of them ends up being negative 1/5, and the other is 6. And so negative 1/5 and 6. And so since x is time and y is height, this negative number doesn't make sense for time. Okay, and so when you're doing an application problem, you're going to choose the positive one, because this, you really only want to focus on the first quadrant. You want to focus on positive height, positive time.